Okay, so today we're going to cover sections 10.4 and 10.5. There are two essential questions since we have two sections. The first one is, what are the four types of angles that can occur with a circle, and how do you find the angle measure given the arc measures for each? And then essential question number 2, what does the theorem about a quadrilateral inscribed in a circle state? So what does that theorem say? So throughout, if you guys need to pause, let the sub know so that she can pause it. All right, so the first main idea is going to be 10.4. And so first we're going to review central angles. So it doesn't hurt to put this so that all of these angles are together in one day of notes. So there was the central angle that we talked about back in the first section. It's an angle whose vertex is on the center of the circle. So this angle here in black is a central angle because the vertex is on the center. The reason why I put the X's there is that the measure of the central angle, whatever degrees that is, will be the same measure as its arc right there. So the arc goes from here to here, if I can get this to right. I want it to. So from here to here, that arc, whatever that angle measure is, so this pi piece, when it's on the center, that arc and angle will have the same measure. Okay, so it's important to keep that straight for a central angle. Its arc and angle are the same. So the angle equals the arc measure. Okay, if you want equations to go with these. The next angle we need to talk about is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So there's a picture down here. So an inscribed angle is an angle whose vertex is on the circle. So the vertex here, see the dot, is on the circle, and whose sides contain chords of the circle. So the two sides of this inscribed angle are chords. And we talked about what chords are. What we call the intercepted arc is the arc that lies in the interior of an angle in a circle. So this arc right here is the intercepted arc of this inscribed angle. So this pi piece looks way different. This would not be a way that you would cut a pi. So I don't like to say pi piece when it looks like this. So when you have an inscribed angle where the vertex is on the circle like this, then when you follow the sides, the arc that goes with it is the arc that's inside, and we call that the intercepted arc. Now, how this relates is this angle is going to be double, or I'm sorry, the arc is double whatever the angle is. So if you wanted to write an equation like I did before, if you were having to find the angle measure, that's going to equal whatever its arc is divided by 2. So what the picture is showing you is that the measure of this arc is going to be double whatever the measure of this inscribed angle is. Or if you want to write an equation in terms of the angle, so the angle is going to equal the arc divided by 2. Okay, because the arc in an inscribed angle is always bigger, 2 times bigger than the angle. Okay. All right, so then once you copy that down, then go ahead and glue in example 1. So only glue in example 1, so go ahead and pause while you do that. All right, so then now we're going to use some information that we know here and try and find the indicated angle or arc. Okay, So part A, we want to find the measure of angle HGF. So remember, you follow the letters. So HGF, where's the vertex? Well, the vertex of this angle is located on the circle. So it's an inscribed angle. So you figure out what its arc is. So its intercepted arc is this arc right here, which is 90 degrees. So when the vertex is on the circle here, then what do we do to find the measure of the angle? Well, remember I gave you that equation that says angle equals the arc divided by 2. So I don't know the angle, I'll call that x, equals its arc, which is 90 degrees, divided by 2. So that means my angle that I'm looking for, HGF, is 45 degrees. So my angle was HGF, and that's its intercepted arc was 90, so you cut that in half, and it's 45 degrees. Okay. All right, part B. So on this one, we want the measure of that red arc, TV. And they gave us the inscribed angle, because if you follow the angle that goes with it, the vertex is on the circle. So then we know that angle equals arc divided by 2 when it's an inscribed angle. Well, this time we know the angle is 38 degrees. We don't know the arc, so that's my x divided by 2. So then how do we solve here for x? Well, we multiply by 2. So then my arc, which is what my x is this time, which is the measure of arc TV, is going to equal 38 times 2, which is 66. Nope, sorry, 76. On some mental math here. Degrees. Because we took 38 and multiplied it by 2. So those are examples. Part A is what you do when they give you the arc and you need to find the inscribed angle. Take the arc and divide by 2. When they give you, part B is when they give you the inscribed angle 38 and you want the arc, the intercepted arc, so then you take the angle and double it, so times it by 2 to get the arc. Okay, so then on the next one, part C, put it over here. They want the measure of angle ZXW, which is in red here. ZXW, so the vertex of that is on the circle. Okay, and its intercepted arc is this ZW here, from here to here. Okay, well, we don't know the arc or the angle, but if you look over here, what I'll outline in green, I do have this inscribed angle, which is 72 degrees, and that inscribed angle goes with this blue arc. So if you know the inscribed angle, remember you take the angle and times it by 2. That gives you the arc. So we then know the measure of arc ZW is what? 144 is that measure of this arc in blue. So I know this arc is 144 degrees. Well, now we want to get that red angle, which is also an inscribed angle, and it shares the same arc. So you would take the 144 and divide it by 2, which just ends up being that 72 again. So the measure of angle ZXW is 72 degrees. Now, the reason why that happens, or that's true, because these two inscribed angles are congruent to each other, both 72 degrees, because they have the same intercepted arc. So if they have the same intercepted arc, you take the arc and divide by 2 for both of them, so that's why they're congruent to each other. Those inscribed angles are congruent. So that's always true. If two inscribed angles share the same arc, then they have to be congruent to each other. Okay. All right, so some more notes. We have an inscribed polygon. An inscribed polygon is a polygon whose vertices all lie on the circle. Inscribed polygon, a polygon whose vertices all lie on the circle. So in my picture down here, the triangle is an inscribed triangle because all three of its vertices are on the circle. Or this is an inscribed quadrilateral because all four of its vertices are on the circle. Okay. A circumscribed circle is the circle that contains all the vertices of that polygon. So my red circles here are circumscribed circles because they contain all of the vertices of whatever shape you want to put in there. You could put a pentagon in there, you could put hexagon, whatever you want to put in there. I just showed you two examples with a triangle, an inscribed triangle, and an inscribed quadrilateral. Now this is important because there's a theorem about a quadrilateral that's inscribed in a circle. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So in this, the only way that this works, if you put a quadrilateral in there, so you have all four vertices on the oh my goodness, on the circle, then opposite angles are supplementary. So for instance, the measure of angle F plus the measure of angle D in my picture has to equal 180 degrees. And the measure of angle E plus the measure of angle G has to equal 180 degrees. Which makes sense because all four angles together add up to equal 360. Which is what a quadrilateral, the interior angles of a quadrilateral add up to equal. So if you have a quadrilateral that's inscribed in a circle, then it's always true that the opposite angles are supplementary to each other. So then go ahead and glue in example 2 so we can look at that. Because that's going to help us with this. Okay, so on example 2, part A. So since we have a quadrilateral that's inscribed in a circle, we know that the opposite angles have to add up to equal 180. So I know y, whoa, that's weird. Y plus 75 has to equal 180. And then I also know that 80 plus x has to equal 180. Because those are opposite pairs of angles, and according to this theorem, they're supplementary. So when you subtract the 75, y is going to be 105 degrees. And when you subtract 80, x has to be 100 degrees. Okay, so you go ahead and pause, and then you try part B. Okay, so on part B, again, opposite angles are supplementary when you have a quadrilateral inscribed in a circle. So then 2a plus 2a has to equal 180. And then we know that 4b plus 2b has to equal 180. Well, now it's algebra, so that's 4a equals 180. So divide. So a is going to be what? See, that'd be 45. Yep. And then this would be 6b equals 180. So then b would have to equal 30. And here they were just asking you for the value of the variables. So that's an example of how that theorem is going to help you solve problems. Okay. All right. So leave a little bit of room. So maybe leave 4 or 5 spaces, or if you're done with that page, move on to the next page and do section 10.5 is the last main idea. So here are other angle relationships with a circle. So vertex is on the circle. This is not, angle 1 and angle 2 are not called inscribed angles because they're not the full definition. The full definition says the vertex has to be on the circle, but it also says that both sides have to be chords of the circle. And notice this side is not a chord. So it's not technically an inscribed angle, but we treat it the same way. So if I was trying to find the measure of angle 1, the angle is still going to equal the arc divided by 2. So even though technically it's not an inscribed angle, we still treat it the same way when we're doing angles and arcs because the vertex is on the circle. Same with angle 2. I would take its arc, which is this major arc, BCA, and then take that measure and divide it by 2. If I was finding the measure of angle 1, I would take arc BA, minor arc BA, divide it by 2, and that would give me angle 1. Okay. The next one is what we do when the vertex is inside the circle. So notice for angle 1, the vertex is somewhere inside the circle. It's not on the center, so it's not a central angle. It's just somewhere inside the circle. Well, what you're supposed to do for this one is you are going to take the arcs. There are 2 arcs. So we look at this arc right here goes with angle 1. And then we also look at the arc of the vertical angle to angle 1. So angle 1's vertical angle is there, so its arc is AB. So when the vertex is inside the circle, I'm looking at angle 1, then to find that angle, I average the 2 arcs. So arc plus arc divided by 2. And the 2 arcs, the first arc is the arc, so here's angle 1, so it's the arc that goes with angle 1, which is DC in my picture. And then you find the vertical angle arc, which is this right here, and it's arc AB. So for this one, so angle 1 would equal the measure of arc DC plus the measure of arc AB, all divided by 2, if I was finding angle 1. And then if I was finding angle 2, I would take the measure of arc BC plus the measure of arc AD and divide that number by 2. Okay, so if the vertex is floating somewhere inside the circle, it's not on the center, but it's somewhere inside the circle, you find the 2 arcs, so the arc and then the vertical angle arc, add them and divide by 2. Okay. The last one is when the vertex is outside of the circle. Get rid of that shade. Okay. So notice on this one, the vertex is outside. If I'm looking at angle 1, the vertex of angle 1 is outside of the circle. So again, you still have 2 arcs to find. You have this arc BC and then the other arc AC here. Okay, because those are the 2 arcs inside of this angle. Now with this one, you're going to find the angle, you subtract the arcs and divide by 2. And you always subtract the bigger arc from, or the smaller arc from the bigger arc. So, and this one, arc BC, the measure of arc BC is going to be bigger. So I would take the measure of arc BC. So for the measure of angle 1, I would take the measure of arc BC and subtract the measure of arc AC and divide that by 2 if I was finding angle 1, just so you have a reference here. So it's always the bigger arc minus the smaller arc divided by 2. And the bigger arc is always going to be the arc the furthest away from your angle that you're finding. Okay, so there are 4 possibilities with these. So the main thing is to ask yourself, where's the vertex before we do the other 2 examples, okay, or the other few examples. So you ask yourself, where's the vertex? If the vertex is inside the circle, so that's when they cross like this, not on the center, okay? Then you do, to get angles, so if I label this angle 1 here, I was finding this angle, you do arc plus arc divided by 2. Okay. If the vertex is outside of the circle, so that was the last one we just did. So if I had that, and I'm finding angle 1 here, then I find the 2 arcs here and here, and you would subtract them. Arc minus arc divided by 2 equals the angle. If the vertex is on the circle, so there's my vertex, it's on the circle right there, okay? So then again, if I was finding this angle 1 here, this one you only need 1 arc because there's only 1 intercepted arc. So then that would be arc divided by 2 to find the angle. And if the vertex is on the center, like this, so there's your vertex, there's the center, and it's on the center, then you only have 1 arc again right here. So angle 1, you only have 1 arc, but if the vertex is on the center, then the arc and the angle are equal to each other. So that is what you're going to have to remember. You ask yourself, where's the vertex? Inside, outside, on the circle, or on the center? Once you have that figured out, then that tells you what equation you're going to use. Okay, arc plus arc divided by 2 if it's inside, arc minus arc divided by 2 if the vertex is outside the circle. If the vertex is on the circle, it's arc divided by 2 to get the angle. And if the vertex is on the center, the arc and the angle are the same measure. Okay. All right, so go ahead and glue in examples 3 and 4. Now, example 4 is actually going to need to go in the big column just because I couldn't shrink it down enough. So example 3 you can still put in the skinny column, but put example 4 over in the big column. Okay, so you have enough room. All right, so example 3. So again, when it comes to these angles and arcs problems, you need to ask yourself, where's the vertex? So part A, where's the vertex for measure of angle 1, which is what we want? It's on the circle, okay? So then that means we find the arc, which if you follow the sides, the arc goes from here all the way to here, which is 210 degrees. So the measure of the angle is going to be the arc, 210, divided by 2. So the measure of angle 1 is 105 degrees. That's your final answer. Okay. On part B, we want to solve for x. So notice x is this angle with vertex C. So then you ask yourself, where's the vertex? The vertex is outside. So that's this formula. Angle equals arc minus arc divided by 2. So I'm going to plug in all the pieces that I know. So the angle is x degrees. The arcs, if you follow, it's this arc and this arc. From D to B, which is 76, and from D to A, which is 178. We always take the bigger arc minus the smaller arc. You can't have negative arc measures, divided by 2. So then, what is that? That's 102 divided by 2. So 101 degrees. Nope, 51 degrees. I don't know what I was thinking. There we go. Okay. All right, and then the last one is part C. Now notice our variable is on an arc this time. It's on arc AB. So if I look for its vertical arc, it's right here, which is DC. But I don't have the angle that goes with those, because remember those vertical angles are congruent to each other. So we need to figure out this angle here next to it. And so I would just do a linear pair. 180 minus 102 gives me 78 degrees for this angle. Now the vertex that goes with this angle, even though the arc is y, the angle that goes with that arc, the vertex is inside the circle. So then I know I'm using this formula. Angle equals arc plus arc divided by 2. So if I plug in what I know, the angle measure is 78 degrees. The two arcs are y plus 95, and that's all divided by 2. Okay. So now I'm going to do math, some algebra. So times 2 on both sides to get rid of that. So what is that? 156 equals y plus 95. Then we want to subtract 95 from both sides. So then on this one, y is going to be 1, that'll be now 14. So was that 51? Now we can check ourselves. So let me double check. If I add 51 and 95, so if we added 95 and 51, we would get 146. And if I take 146, oh, nope, that should be 61, shouldn't it? That's going to be 61. Doing mental math today is not working out for me. So we need it to equal 156. And so I didn't need to cross out, that's going to be 15. So that would be 61 there. So 61. So that makes sense now. 61, that's 156, and 156 cut in half is 78. There we go. So the answer is 61 degrees. Good job if you guys caught that. Okay. So again, you're asking yourself, where's the vertex? Because the pictures aren't always going to be nice like number 3. If you look at example 4, lots. I mean, it's a lot going on in this picture. Okay. Now, here's what I recommend you do on these types. First, you put in all the given information and find all the arc measures. So they're telling us that line BZ is tangent, so we know it hits at one point at point B. Circle O means O is the center point, so we know O is the center. Segment AC is a diameter, so that cuts it into 2 semicircles. Measure of arc BC is 90 degrees, so I'm going to put 90 there. Measure of arc CD is 30 degrees. And measure of arc DE is 20 degrees. Now, I'm missing arc BA and I'm missing arc AE. So I'm going to find those first before I go on and try and find all the angles. So since AC is a diameter and BC is 90, what's the measure of arc AB going to be? 90 degrees. Okay. Now, remember, AC is a diameter, so that means this bottom half here, arc CEA, is semicircle, which is 180, and we know this is 30 and 20. So what does AE have to equal? Hopefully you're saying 130 degrees, because you do 50 subtracted from 180. Okay, now you have all the arcs, and that's going to help. Okay. Now, angle, we want to find the measure of angle 1 first. So then you ask yourself, where's the vertex? The vertex for this is on the center. So then I have these here. Whoops. I have these here to kind of cover up. So angle 1 is this, and then it's here. So you might have to just cover up some stuff for yourself just to help out. So angle 1, if you use your hands, angle 1, and I ignore the rest of this, goes with this arc 90. When the vertex is on the center, what do we know about the central angle and its arc? They're congruent. So the measure of angle 1 is going to be 90 degrees because it has to be the same as its arc. Okay? Keep forgetting. All right, so then I'll move these out of the way for a second here. Okay, now we want to find angle 2. So let's mark. The vertex for angle 2 is right here. So where's the vertex? Vertex is on the circle. So this means we take the arc and divide it by 2. So now I'm going to cover up some of this business. So angle 2 goes that way, and angle 2 goes this way. Okay, so the vertex was on the circle. When you follow the sides, notice it's this arc right here with the 90 plus 90, which is how many degrees is this total arc? 180. So remember, when the vertex is on the circle like this, we take the arc and divide it by 2. So what's 180 divided by 2? 90 degrees. And if you want to put these angle measures in your picture, you can. Whoops. So if you want to mark that it is, you know, the angle 1 is 90 and angle 1 is 90 and angle 2 is 90, you can in your picture. I'm not going to because I just want to have a bunch of busy stuff. Okay, now we're finding measure of angle 3. So notice for the measure of angle 3, the vertex is on the circle, which is A. So again, we're going to find the arc and divide it by 2. Because when the vertex is on the circle, you take the arc and divide it by 2. And again, you could just use your hands to cover up stuff if you get too confused with the picture. Okay, so there's angle 3. Its arc is from E to C here. Well, how many degrees is that total arc? That total arc is 50 degrees, 30 plus 20, 50 degrees. So remember, when the vertex is on the circle, we take 50 and cut it in half. So that means that that is 25 degrees. So we just did 50 divided by 2. You don't have to show the work, but I'm just kind of showing you how I got that. So again, the big question is, where's the vertex? All right, next, we want angle 4. So angle 4, the vertex is on the circle again at point C. Okay, so when the vertex is on the circle, whoops, angle 4. When the vertex is on the circle, we have to take the arc and divide it by 2. So if I cover everything else up and just follow the edges of the angle, I see that it goes with arc 130. And so I take 130 and divide it by 2, and you get 65 degrees. Okay. Now this video is on Schoology, so if you need to go back and rewatch this, you can. Okay. All right, angle 5. So again, the big question is, where's the vertex? Well, angle 5, the vertex is right here. Okay. Now this one, the vertex is inside the circle. Okay. So if I follow this side up, this one's a little harder to do my blackout things, and follow this side all the way up. So 90 degrees is one of my arcs. Then remember, you have to find the vertical angle to it, which is right here, and find its sides here and here. So that goes with this arc 20. So remember, when the vertex is inside the circle, what do I do with the 90 and the 20? Well, you're supposed to add them and divide by 2. When the vertex is inside, you find the average of the 2. So you add 90 and 20 and divide by 2. So it's 110 divided by 2, which is 55 degrees. Okay, so that's measure of angle 5. Now, notice that we know that angle 5 is 55 degrees and angle 6 is right next to it. Don't forget linear pairs. You could find the arcs for angle 6 and add them and divide by 2, but a lot faster, since I know angle 5 is 55 degrees, I could just do a linear pair and get the answer a lot faster. So then I would do 180 minus 55, which would give me what? 125. So the measure of angle 6 is 125 degrees. You could, like I said, still find the two arcs that you need to add and divide by 2, but since you know angle 5 and they're a linear pair, you might as well just do it that way. Okay. All right, angle 7. Notice the vertex is outside of the circle for angle 7. So you need to find its two arcs and divide by 2. So if I follow this along, angle 7 side goes there and there. So then the two arcs that we care about is AB and DE. When the vertex is outside of the circle, what are we supposed to do with the two arcs? You're supposed to subtract them. Big arc minus the smaller arc. So 90 minus 20 divided by 2. So 90 minus 20 is 70, divided by 2 is 35 degrees. All right, almost there, home stretch here. All right, so that's that. That was angle 7. Okay, angle 8. So again, you ask yourself the same question. Where's the vertex? So angle 8, the vertex is here, which is somewhere inside the circle. So angle 8 goes to here and here. So I care about this arc, 90 degrees. And then you look at its vertical angle there and find its arc, which is arc DC. So when the vertex is inside, what do we do with the arcs? We add them. So for 8, I'm going to do 90 plus 30 divided by 2. So what is that? 120 divided by 2, which is 60 degrees. So angle 8, the vertex was inside. You find the two arcs that it goes with it, its vertical angle arc and its arc. Add them and divide by 2. All right, next one. Oops, that was 90 over there. What happened to that? Okay, so then FBO. So remember when you give them 3 letters, it's the middle one. So FBO. So B, the vertex is on the circle. Now this one is actually a review from something we did before, because you can't actually follow it because O is not on the circle somewhere, like it doesn't end on the circle. And this is an essential angle because even though O is the center of the circle, B is the vertex. But this goes back to the radius tangent theorem we did in that first day. When you have the radius drawn to the point of tangency, it always makes a right angle. So that was one of our theorems we did on the first day of notes. So then that means that the measure of angle FBO has to be 90 degrees. So that was the radius tangent theorem, that if you have the radius drawn to that point of tangency, it always makes a right angle. All right, and then the last one, we need the measure of angle DBZ. So B is the middle letter. So DBZ, so the vertex is on the circle. So the sides go here and here. So the arc we care about is here in blue, from here to here. Well, we have to figure out that arc, we do have to add. So 90 plus 30 is 120. And since the vertex is on the circle, you take the arc, 120, and divide it by 2, which is 60 degrees. Okay, this is the most complicated the picture will get, and you will see something like this similar to either on the quiz or the test or both. Okay, so like I said, the big thing is asking yourself, where's the vertex when they want you to find an angle, or if they give you an angle and they want you to find one of its arcs or its arc. So you have to use these little formulas and plug in what you know and solve for what you don't know. So whatever you don't know, I would suggest you call that your X value. Okay. So that's the big trick on this. Especially when it looks like this, it's not so bad, you know, because you can tell right away what it is. But when you have a complicated picture like this, you got to kind of break it down. Ask yourself, where's the vertex? Locate the arc or the two arcs that you need, depending on the equation, and then perform the operation. Okay, so your assignment is a worksheet. There is a hard copy for everybody, but it is on OneNote. So for those of you that would rather just do it on OneNote, you can. Otherwise, if you want a hard copy, let the sub know so she can give you one. Okay? All right, so your assignment is just that worksheet. Make sure you do a repetition now, and remember you do a repetition tonight when you get home and you've stepped away from these notes.